So choosing sample size, we're going to introduce a little bit of algebra that you'll have to do for this part of 8.2. But when you plan a study, generally you'll know what size you want the margin of error to be. So as long as you know how big you want that margin of error to be, meaning how precise you'd like your interval to be, we have the ability to solve for what sample size we need to select. All right, remember this is how we calculate margin of error for a confidence interval. It's what we call a critical value, and that comes from what level of confidence we want to have. Remember, it's a z-score, so it's just the number of standard deviations to either side of our point estimate that we want, times what we call the standard error. And the way that standard error is different from standard deviation, remember, is just that we're using p hat because we don't know p. P is what we're trying to figure out. But that's how we compute the margin of error. And so, namely, what you're going to be able to do is you'll know the margin of error, so we'll decide what we want that to be. We'll know our confidence level, so we'll be able to figure out our z critical value. You can potentially know your p hat. If not, I'll tell you how we kind of get around that. And then what we're going to do is solve for the sample size. So to calculate the sample size, substitute in values for margin of error, your z critical value, and p hat, and then we'll solve for n. Here's the problem with this. We're doing this before we conduct the study, so we likely won't have a value for p hat until after the study. This means we'll have to guess the value of p hat when choosing n, and there are two ways to do this. Number one, just like TV shows, sometimes studies have pilots. So they're like, oh, okay, we don't know if we want to full-on finance an entire study. Let's say we have some hypothesis. Let's go out there and gather a little bit of data first and do like sort of a pretend version of the study. So if there was a pilot study, then you can use the value you got from the pilot study for p hat, right? So if you have some information about p hat, you can use that. If not, you want to be as conservative as possible when choosing a p hat. So you want to choose p hat so that it's going to give you the largest sample size possible when you solve for sample size. So let's see, I have a couple students in here that were in calculus. You guys remember optimization? It just means finding a maximum. So what value of p hat would make this numerator the largest it could possibly be? So think of it this way. What values does p hat have to be in between? It's a proportion, right? So it has to be between 0 and 1, right? And remember that these are going to complement each other. So if p hat is 0.1, then 1 minus p hat is 0.9. And then when you multiply those together, you would get 0.09, right? But I want to choose the value of p hat that would make that numerator the largest possible. So if p hat is 0.4, what's 1 minus p hat? What's 0.4 times 0.6? What's 6 times 4? Yeah, 0.24. That's definitely larger than 0.09, right? I'll tell you this, when they're at the extreme ends like this, it's going to produce a smaller product. You're close. There's one that can be larger than that. It's 0.5 and 0.5. 0.5 times 0.5 is 0.25, and that's the largest possible product. So that's the other thing to do. Just use 0.5, and that'll make our margin of error the largest it can possibly be, which is going to give us the most conservative estimate for what our sample size should be. All right, so two decisions. One, if we have a pilot study, just use the p-hat that we got from the pilot study. If we don't have a pilot study, just use 0.5, because that's being as conservative as possible. Did we go over last time how to find the z critical value in your calculator? Oh yeah, we did, right? Because I said it's area to the left. Okay, I'll remind you guys. It's inverse norm, yeah. If you just want the z critical value. All right. So we'll review that here. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company, I think those are our betters. Here, use this one. The company president wants some idea of the sample size that she will be required to pay for. One value of interest is the proportion P of customers who are satisfied with the company's customer service. She decides she wants the estimate to be within 3 percentage points at a 95% confidence level. How large a sample is needed? Okay. This 0.03, that's our margin of error. So she knows that she wants her margin of error to be 0.03. And so the way we're going to compute this is we're going to have a z critical value times our standard error, which is p hat times 1 minus p hat over n. And we want that to be less than or equal to 0.03. So less than or equal to our margin of error. All right, the z critical value, here's how we're going to figure that out. That comes from our confidence level, which we want to be 95%, meaning I want to know the z-scores that will bound 95% of the data, so 0.95 in there, right? We said we can use inverse norm. The area to the left, you can use either z-score, remember. If you choose to do this one, it's going to come back negative, so you just need to make it positive. But how much is left over in the tails? 0.05 total, and then so how much in one tail? 0.025. So if I want to find this one, I need to enter all that area, which is 0.95 plus 0.025, so 0.975. And then we'll just go, our mean is 0 and our standard deviation is 1. All right. So that's going to be in your distribution menu. So second variables and then inverse norm area 0.975. There we go. We get about 1.96, and that's our critical value. All right, so our z critical value is 1.96 times the square root. Now, is there anything said about a pilot study in this example? I don't see it. So what should we use for our p hat value? Okay, that means our numerator is just going to be 0.25, right? Over n is less than or equal to 0.03. And now we're ready to solve for our unknown. We want to solve for n, so a little trip back to algebra 2 for you here. First thing I would do is divide out the 1.96, so I end up with 0.25 over n is less than or equal to 0.03 over 1.96. Got to get rid of the square root, so let's square both sides. 0.25 over n is less than or equal to 0.03 over 1.96 squared. And I'm not going to, don't simplify, don't actually punch this into your calculator until you've isolated n. All right, now I need to get n in the numerator. So what we're going to do is multiply n to this side. Yeah? And then we're going to divide this big mess over here. So basically n and what's on the right-hand side there are just going to swap places, right? And notice that then I'll have n is greater than or equal to, since n's now on the right-hand side. And it's going to be 0.25 divided by the quantity 0.03 over 1.96 quantity squared. All right, so let's do this in the calculator all at once here. So 0.25 divided by open parentheses 0.03 over 1.96 quantity squared. It should be pretty obvious if you get an insane answer. Remember, what we're solving for is sample size. So if you get like a negative number or, you know, some decimal less than 1, probably just some clerical error when punching it into your calculator. All right, but that seems reasonable. We want to be as conservative as possible, so you can't sample 0.1 repeating people. So we're just going to round this up to 1,068 people. That's how many they would want to survey. Good? Questions?
Would it be n is greater than or equal to?
This is how many you would want to sample. N is greater than or equal to the decimal that we solved for, but this is how many you want to sample to make sure that your margin of error is within 0.03. All right. There we go. That's all the work we just did. Here's our last one. Let's do 2017 AP Stats. Here's a free response question from that 2017 administration of the exam. The manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the beverage fountain instead of filling up the cup with water.
Who would do that?
This manager seems like a miserable human being. It costs, he's not the owner even. That costs the restaurant like literally 2 cents.
It's like some teenager who just like really everything.
The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 filled the cup with a soft drink from the beverage fountain.
My mom Yeah. I've like never done this.
You just gotta go with a clear one. You gotta go with Sprite.
Or like, when I was little on oysters, and you put water, and you put like a tiny bit of lemonade in it, just like a little bit. I also thought it was illegal. I'm not even kidding.
All right. Construct and interpret a 95% confidence interval for the proportion of all customers who have asked for a water cup when placing an order and fill the cup with a soft drink from the beverage fountain. All right, we're going to do this one all the way through. So I'm going to go state just to organize my thinking. Here's what we're interested in, P. That's the true proportion of soda thieves. What we're going to do is we want a 95%, yeah, confidence interval for a proportion. All right, so I'll go to plan. This is where we check our conditions. So I'm going to say stated as a random sample. And then they did 80 customers. If we multiply that by 10, that's 800. And we'll just say, safe to assume the restaurant has greater than 800 customers. All right, large counts would be our sample size, which is 80 times our p hat, which is what, 23 out of 80? Which is 23, which is definitely greater than 10. And then finally 80 times 1 minus p hat, which I guess would be 57 out of 80, which is 57, which is also greater than 10. All right, so I'm on do. We want a 1 prop z int. So stat tests. It's 23 out of 80. I just want a 95% confidence interval. All right, that gives me 0.188 to 0.387. And finally, we'll conclude. We're 95% confident that the interval from 0.188 to 0.387 contains the true proportion of soda thieves. All right, so that's A. We actually constructed the confidence interval and interpreted it. All right, so now let's answer B. The manager estimates that each customer who asks for a water cup that fills it with a soft drink costs the restaurant 25 cents. I don't believe that. That soda syrup costs like 3 cents for 5 gallons. Suppose that in the month of June, 3,000 customers ask for a water cup when placing an order. Use the confidence interval constructed in Part A to give an interval estimate for the cost of the restaurant in the month of June. All right. So we said basically between 18 and 38% of customers are stealing soda, right? So we can convert that into actual numbers. If there are 3,000 customers, I can go, okay, well, what's 18.8% of 3,000? So that would be 0.188 times 3,000. So that's 564 of those customers are stealing soda. And this manager said it costs them 25 cents per customer who does that. So if we multiply that by 25 cents, that translates to $141, right? Everybody follow that logic? Can you guys figure out what the upper boundary would be on how much money we lost? So the upper proportion was 0.387. Jesus. Yeah, times 0.25. So 290.25. So $141 to 290.25. So that would be our answer to part B. By his estimate, the restaurant loses somewhere between $141 and $290.25.
A lot.
That's some.
That's maybe like 3 paychecks.
All right.